Hello student, this is a new chapter that is a matrices, and in this chapter we will learn the elementary transformation, inverse of a matrix by the elementary transformation method, adjoint method, applications of matrices, that is a solution of a system of linear equation by the method of inversion and the method of reduction. Now this is very simple topic, that is a elementary transformation. And what are the elementary transformation, how they happens. Now we will learn this from this exercise. I will explain whatever the problems are given in this exercise, that is a 2.1. Now let us start. The first example. Apply the given elementary transformation on each of the following matrices. The first example, the matrix is 1 0 minus 1 3. I will always read the matrix in this manner, that is first row, second row, third row in this manner, that is 1 0 minus 1 3. Now here is a transformation is that R1 2, that is interchange first row to the second and second row to the first. Very simple operation. R1 2 gives, that is minus 1 3 1 0. This is operation, that is a first row to the second and second row to the first. Now the next is, these are called the elementary transformation. Now the second example, that is a B 1 minus 1 3 2 5 4. Now what is here? This indicates that this transformation indicates that R1 changes to, this arrow implies that its R1 changes to R1 minus R2. R1 changes to R1 minus R2. It means that from the first row subtract the second row. In this case, the R1 is remain unchanged. It is as it is. Therefore, we'll first of all, R2 remains unchanged. That is B is equals to, see this here, R1 changes to R1 minus R2. R2 remain unchanged. Now we'll subtract R2 from R1. Now see this here, that is a 1 minus 2 minus 1 minus 5 3 minus 4. Therefore you will get, this is the answer, that is minus 1 minus 6 and minus 1 2 5 and 4. Now you can see this again here. This is the operation, that is R1 changes to R1 minus R2 gives 1 minus 2 minus 1 minus 5 3 minus 4 2 5 4. And after this simplification, you will get minus 1 minus 6 and minus 1, and the second row remain unchanged, that is a 2 5 4. Now see this again here. The next example, example number 3. See this example. A matrix is given, that is a 5 4 1 3 C1 2, that is interchange first row to the first column to the second and second to the first. And in the second example, what's R1 2? Change the first row to the second and second to the first. Now see this one by one. The first matrix, that is a 5 4 1 3 C1 2. We get this, that will interchange the first to the second, second to the first. Now what is the second column? Is a 4 3. Here is a 4 3. And what is the first column? 5 1. Here is a 5 1. This is the, and the next for the B matrix 3 1. Now we'll change, interchange R1 2. Therefore you will get, that is a use 4 5. Now this is second row, it will come in the first row and first row to the second. Very simple. Now, what is your conclusion? That is, if you perform both the operation and the answer is same, the two new matrices are equal. Now the next is a matrix A is given, that is a 1 2 minus 1 0 1 3. Now what is the operation? That is a 2 times C2, that is a multiplied 2 by the second column. And what is here B? B is a 1 0 2 and second row is 2 4 5. It says that multiplied first row by minus 3 and find the addition of the two new matrices. Now we'll see here, that is matrix A 1 2 minus 1. This is the first one, that is a 2C2, that is we will multiply the second column by 2 1 0 4 2 minus 1 3. Next is B matrix 1 0 2 2 4 5 multiplied by minus 3 to the row 1 minus 3 R1. Therefore you will get, that is a minus 3 0 and 6. Now these are the two new matrices. Notice again next the addition of the two new matrices. Now we will add these two matrices, that is A plus B. These are the two new matrices. This is the second. Therefore now see this, these two matrices we will add this. Therefore the answer is first is 1 minus 3. It is a minus 2. 1 minus 3 is minus 2. Second one 4 plus 0, that is a 4. And next is minus 1 minus 6, that is a minus 7. And the next is 0 plus 2, it is a 2. 2 plus 4, that is a 6. 3 plus 5, it is 8. Now you can see this again here. This is the question number 4. This is the answer. Now the question number 5. That is matrix A is given 1 minus 1 3 2 1 0 3 3 1. What is the operation? That is a 3 times R3 and then C3 plus 2 times C2. Now we'll perform one by one operation. The first operation is a 3 times R3, that is we'll multiply 3 by to the third row. Now see this here, the 1 minus 1 3, these are the first row, it remain unchanged. Second row is also remain unchanged. Write down it 2 1 0 2 1 0 and multiplied the third row by 3. Now 3 into 3 is 9, 3 into 3 is 9, 1 into 3, that is a 3. This is our first operation. What is the next operation we want to perform? That is a C3 plus 2 times C3. C3 plus 2 times C3. Now this operation is a. Now see this here. This is the second column and this is the third column. In third column we are adding, that is a 2 times C2. Now first of all minus 1 into 2. Minus 1 into 2, that is a minus 2. Plus 3, we get 1. Minus 2 plus 3, 1. Next is a 2 into 1, 2. 2 plus 0, that is here is a 2. Next is a 9 into 2, 18. 18 plus 3, which is the 21. And this is the final answer. Now the same is I am repeating here. That is a 3 times R3. Then you will get, that is multiplied the third row by 3. 9, 9 and 3. Now the next operation is, that is a transformation, is C3 plus 2 times C2. That is, we will add in C3 2 times C2. Now which columns are remain unchanged? That is, the first is remain unchanged. Therefore it is a 1, 2, 9. And second is also minus 1, 1, 9. Now in third, that is a C2 minus 2 is 1, 2 and 3 plus 2 times C2, that is a 2 times 9, 18 plus 2, that is a 21. This is the new matrix. Now the next is question number 6. Now see this here. A matrix is given, that is a 1, minus 1, 3, 2, 1, 0, 3, 3, 1. What is the operation? C3 plus 2 times C2 and then 3 times R3. Now we continue the steps one by one. Our first operation is, that is C3 plus 2 times C2. In third column, that is a 1, 2, 3, this remains as it is, minus 1, 1, 3 and 3 plus into minus 1 into 2, this is a 1, 2, that is 1 plus 6, 7. And the next operation is a 3 times R3, that is, we will multiply by 3 to the third row. Therefore it is a 9, 9, 21 and this is the answer. Now if you see this, it shows that transformation is a commutative. Now see this again here. Example number 5. This is the operation. 3 times R3, then C3 plus 2 times C2. We get this. And what about the sixth one? Here is a first operation is a C3 plus 2 times C2 and the second operation is a 3 times R3. Therefore we'll addition of these two. Then we'll get 1 minus 1, 1, 2, 1, 2, 3, 3, 7 and 3 times R3. Then you will get 1 minus 1, 1 and 2, 1, 2, 9, 9, 21. And in this case, that is, we get these two operations. If we perform the operations, that is, first operation is a 3 times R3 plus C3 plus 2 times R3. And if we change the order on another matrix, that is in example number 6, we perform this C3 plus 2 times C2 plus 3 times R3, then the both are the equal. Therefore, the matrix operations are, transformations are the commutative. It doesn't affect on the value of the matrix. Now the next example. Here is a 3 times R3. This is the first transformation which was in the example number 5, and this was the second transformation, that is a C3 plus 2 times C2. This was the second. For the same matrix, second transformation, and C3 plus 2 times C2. If we perform this operation first and then 3 times R3. The value remains unchanged. Therefore, we say that the transformation is a commutative. Now the next question is question number 7. Use the suitable transformation, that is a matrix 1, 2, 3, 4, to convert it into an upper triangular. To make the upper triangular, if we join this diagonal, makes this element 3 as a 0. And it's very simple. What is the operation? R2 minus 3 times R1. This will become 0 and we get our proper result. Now see this here. That is 1, 2, 3, 4. R2 minus 3 times R1. This is my operation. That is 1, 2. First row remain as it is. 3 will become 0. And 0 minus 2. 0. Now we get this is an upper triangular matrix. It's a very simple. You can see this also here. Now the next is question number 8. That is a convert 1 minus 1, 2, 3 into an identity matrix by suitable row transformation. Now identity matrix means what? Here is a 1, 0, 0, 1. Here is 1 as it is. We make here minus 1 as a 0. For the 2 it is a 0 and for the 3 it is 1. Now what is the sequence to do this? The sequence is that first of all this first element which is called A11. This is 1. And this element is a A21. Make this A21 as a 0. Now first this will be 0. Next is whatever the element will be afterward here, make this 1 and then this is 0. Now we'll follow the step by step. Now we'll make the A21 element as a 0. Then what will our operation? That is R2 changes to, now see this first. My operation is a R2 changes to 2 times R1. Then you will get 1 minus 1. This will become 0. And this will be 5. That is 3 minus 2 minus 1. That is a plus. That is a 5. This is my first operation. Now we'll make here 5 as 1. And making this 1, we'll make minus 1 as a 0. To make this 5 as 1, we will have the operation that is 1 upon 5 R2. Then we'll have there 1. Next operation is a 1 by 5 R2. Then you will get 1 minus 1 as it is. First row is as it is. Therefore, we will write the first row. And the second row is a 0, 1. This is, and the next is, if we add this, that is R1 plus R2, that is minus 1 plus 1, that will become 0. And 1 plus 0, it remains unchanged. Therefore, we get the identity matrix R1 plus R2, that is 1, 0, 0, 1. And this is our required result. You can see this here. Now the next is, this is required result. Transform 1 minus 1 2 2 1 3 3 2 4 into an upper triangular matrix by suitable column transformation. That is, if we join these, then we'll make this 2, 3 and these 2 as a 0. But it is by using the column transformation. For that, first of all, my operation is that this 4 I will make it as a 1. By using this 1, this 2 will become 0, this 3 will become 0. Then whatever that element will be here, then make this 1. Then whatever the element will be here, then make it as a 0. Then we will get our required result. My answer is different from the textbook. If you are agree, then write down it. Otherwise, it is not necessary. Now see this here. 1 minus 1 2, 2 1 3, 3 2 4. The first operation is make this 4 as 1. Therefore, 1 by 4 C3. 1 by 4 C3 because we want to make this 4 as a 1. And using this one, these two will become 0. These remain unchanged. Write down it. This is our priority. That is 1 upon 2, 3 by 4, and this is 1. Now my next operation is that is a C1 minus 3 times, this is my operation, that is a C1 minus 3 times C3 and C2 minus 2 times C3. Now see this here. One upon 2, 3 by 4 and 1. Therefore the next is C1 minus, this is the operation, you can perform it, that is a C1 minus 3 times C3 and now next is C1. Now we have to make this as a 0, to make it 0, that is C1 plus 1 upon 2 C1 minus 1 upon 2 C2, then we will get here 0. See this here, C1 minus 1 upon 2, and if you perform that, then you will get 1 upon 2 0 0 minus 2 1 upon 2 0, 1 upon 2 3 by 4 and 1, and in this way we get the upper triangular by the column transformation. This is my answer. It may be their correction, whatever that I don't know, but I had checked the number of the times, and in this way we have completed the practice set, that is a exercise 2.1. Now we'll see in the next video. Till then, goodbye.